This presentation, titled Wearable Technologies Empowering the Worker, comes to us from Lance Bauerfeind. Lance is an augmented and virtual reality specialist, as well as a senior consultant at multi-award-winning software specialist Company X. His work in the new realities realm is an integral part of the Company X mission to deliver Silicon Valley-level software savvy with a Kiwi can-do attitude. Lance splits his time at Company X between consultancy, research, and strategy, driving innovations in augmented and virtual reality, as well as new technologies, including the Internet of Things and artificial intelligence. Prior to joining Company X in 2019, he worked in the creative industry for more than 17 years as a videographer, producer, television director, and production company manager. And with that, take it away, Lance.
Thank you, Mike. Okay, so I'm here to talk to you about wearable technologies empowering the worker. But first up, before we get into that side of things, I really wanted to start with a quick primer about what has come to be known as extended reality, or XR for short. Essentially, XR covers virtual, augmented, and mixed realities. And think of these technologies as knowledge delivery mechanisms that can be used for different forms of training scenarios, business processes, or simply just sharing knowledge. So if you can think of these two technologies as covering two main categories. First one would be VR, and virtual reality can be defined as an immersive, interactive experience in a created world. First of all, I should actually just mention as well that I really just want to touch on this just to make sure that we're talking the same things and that you understand where I'm coming from when I'm using these terms. So what that means is a VR environment is that is created by humans, by people on 3D and specific platforms to be able to create 3D environments. And what we're doing with virtual reality is that we are then transporting that person inside that environment. And as you can see in the image here, there are actual mobile versions as well, but what I have here is what would be considered a hardwired version. So what the advantage of that is that you get the higher processing power from the computer, and so therefore you can have better quality environments fundamentally. As you can see here, this has outside tracking, so we have two sensors that tracks the controllers in a person's hand and the headset so that we know where they are inside that environment. And I guess the beauty with virtual reality is that everything is controllable. We can have any environments and any scenarios for training. From this perspective, we can have any sort of scenarios that we want to build in. So you build the environment once, but then you can do many different multiple things inside that environment. Augmented reality, on the other hand, is where we overlay the real world with information from the digital world. So if we look at in the bottom right-hand corner there of the devices, we see a smartphone, and a great use case for that now we see with Google Maps is that you can have navigation instructions when you're walking on the street, but you can have arrows appearing on top of the pavement so that when you're getting your directions, you're following these arrows. It's just not voice directions, or I guess trying to figure out how to read a map, which not all of us are great at, right? The other devices we have in this space are like the Microsoft HoloLens, it's a main player as well, and also the RealWear HMT, or head-mounted tablet, which we'll talk about later on. I would say with the head-mounted tablet, it does do augmented reality, so you can overlay onto the screen that's on the end of that arm on it, but it's really, as the name suggests, a head-mounted tablet that's entirely voice controlled. So kind of in AR, but not quite, and sort of an in-between technology that is working very well in industry at the moment. Right, the connected worker. So I think when we're looking at the connected worker, that people interact with many different aspects of a business, so both physically and digitally. By default, when companies think of digital transformation, they think of automation or data systems, for example, and how they can gain, I guess, greater efficiencies, greater knowledge about their processes, their machines, all that sort of thing, and how that can be a benefit to them. But even the most advanced technology today can't fix, adjust, or visually assess a problem with the accuracy and insight that human workers can, which means workers themselves are the most critical source of productivity gains that are available to companies that are digitizing their operations. By extending digital transformation to workers, companies can unlock greater productivity and safety while overcoming the skills gap. So why wearable technology? I guess as the name suggests, wearable technology would suggest that it's mobile. So you don't have to be restricted to a physical location. And as an information delivery device, wearable technology delivers the right information at the right time to the connected worker. So again, when we're thinking about this particular process, or this idea around how we can deliver information, how we can have knowledge transfer between people inside an organisation. What we really want to achieve is the ability to get them exactly that, the right information at the right time. So if we go back to the virtual reality scenario, I guess or the technology, I should say, the scenarios that you build inside virtual reality are kind of like in a just in case. I think if we're looking at wearables and AR and that sort of technology, we're saying that's just in time, and VR would be classed as just in case. So that's where we can put them inside this environment. We can have scenarios. We can train them up that way. And then once they go out into the work environment, they can then call on what they've learned and be able to carry out their tasks. With the wearable technology, they don't need to remember everything that they have, because what we can do is we allow people to connect with remote experts, with somebody else that they can talk to other documents and that sort of thing, so they get that information when they need it for that task. So wearable technology makes work environments safer. It cuts compliance costs. It raises productivity, and it puts the right knowledge in front of workers at the right time, as I was saying. So what are the main use cases? Well, with wearable, so there's a lot of use cases that you could do, and pretty much when we're talking with people that in their own environments, they can pretty much come up with a new use case every time I go and speak to somebody. But fundamentally, the two main ones that we always tend to, or I'd say that organisations find most attractive, and that we always tend to start off at, are two. And the first one would be the remote expert video calls, and the second one would be the guided digital workflows. I mean, there are other use cases for it. We can grab sensor data and get that in front of the worker as well. We can have mobile forms. We can grab sensors from IoT data and visualize that for them as well. But that's the remote expert video calls and these guided digital workflows are the two main use cases that we come across most times. So for the remote expert, what does that look like? So here we have, in this diagram, we have a remote expert. So that can be, anyone. They could be in their office, at home. They could be out and about, but working off their mobile. And you have the technician with the wearable on. And from there, the technician, if they're performing a particular task and they're stuck, they can actually, through their voice, make a phone call back to the expert, and then be able to grab their advice and on how to solve this particular problem. The expert has a number of different tools. He can just obviously talk and tell the technician what they need to do, or perhaps he may want to annotate or draw arrows onto the live video feed so it would appear inside the headset that he's drawn an arrow on this particular circuit breaker, for example, and then he will then know he's going to switch the right circuit breaker off. You can also, the expert could share a screen if you wanted to show him a particular image, whatever that might be. Other ways that it is being used as well is that the technician can, obviously he can take photos. He can then send those photos and videos, whatever it might be, send that back to the remote expert. Also, the expert may want to send PDFs and videos to the technician and say, here's the manual, go to page 124, and this is how you fix this particular problem that you've come across. It may be, have a look at this video. It could be a number of different things. But it's all around this transferring of knowledge to the right person at the right time. And the remote expert is, I was going to say a no-brainer, but it's definitely one of the first ports of call when looking at using wearable technology. The next one, the digital workflow. Well, I guess that can be sort of cookie cutted a little bit into three separate sections. One is creating the workflow, then it's around completing the workflow, and that workflow might be, an audit or an inspection, whatever that might be, and then actually the output of it, the reports. So generally, most of these platforms will come with their own workflow creator, so you can create your own customized workflows, your own inspections for what you need to do. Then they can be loaded onto the wearable device, and then they can go step by step through the process, taking photos and videos when they need to, calling support, the remote expert if they need to. And then out of the end of that audit, once that is completed, then it can be all uploaded to the cloud or to wherever the servers may be, and reports can be created. What they're finding there, they're getting obviously a faster turnaround to get that done. It's better customer service and efficiency around accounts, and being able to get those processed quickly as well. So it's a win-win for all. So now I just have a video for you to take a look at. This is using the RealWear device, and this should give you a good idea of what a wearable works, how it works.
Start inspection. Number of wagons. 10. Confirm. Open camera. Take photo. Open anomaly. Open camera. Take photo. Enter code 322. Call support. I'm performing an inspection on a train, and there's a strong smell coming from the third wagon.
Show me the wagon number and the labels of dangerous goods. It's ethylacrylate, a class 3 flammable liquid. The UN number is 1917.
See. Let me check the
Safety distance. To be safe, stay upwind, 14 meters from the wagon.
I'm sharing with you the safety data sheet.
Toxicological information is in section 11.
Closed inspection.
Blitz ein.
Railcargo Anwendung starten.
Anwendung starten.
Inspektion starten.
Inspektion starten.
Blitz aus.
Blitz aus.
Okay. So I should mention that was provided by video by a vendor called Space One. So thank you to them for that. I'll just need to, looks like I'll need to just click through quickly through the presentation to get us past that video. Here we go. So now I just wanted to quickly touch on an audit trial that we have done. We did that with a company called Assured Quality, and they provide food safety and biosecurity services to the food and primary production sectors, both here in New Zealand and also worldwide. So it's a forward-thinking company that looks for ways to improve their processes to increase efficiency and productivity. So they were looking at this particular question of how can we become more effective and more productive with our audits. And what we decided that what we would do, we would begin a trial, and we started off using a simple phytosanitary audit, as we felt that was the best starting point. You know, start with something small, see how we go, and then move on from there. Before we get there, I guess one of the first questions we ask ourselves is what platform shall we use? And as you can see, there's a number of options available on the market, and actually there's a number that aren't on there that are not around anymore, but were quite, I guess, were market leaders a few years ago. So having seen technologies or companies come and go with devices, it was important to take this into consideration when making our decision. Also, we needed to separate fact from fiction, and having a device that can work in an industrial environment is definitely different to something that can work at home as a consumer product. And it was critical given that nearly all AR devices need certain lighting conditions, for example, to work effectively, as well as there's the durability of the product itself, and what could be wet, dusty, noisy environments. So looking at this diagram here, we can take a look at Magic Leap, bottom left, the Magic Leap in the binocular section. And Magic Leap is a very good device, but it's not suited for the industrial use cases that we were looking at. So then obviously we had to put that one to the side, looking at things perhaps like the Epson above that, the Epson BT 2200. We had tried that out previously, and separating fact from fiction again, I guess it was suitable for very limited use cases. I don't know about the later models now, but that was not one that we decided to go with. So what it got down to for us was the HoloLens, or one of the ones that I've mentioned are no longer with us, ODG. So our selection criteria was primarily around voice. So if possible, completely voice controlled and therefore hands-free. I mean, for development, nearly all AR glasses are Android. The HoloLens is a Microsoft product. So the major question we ask ourselves here is that if we develop for the HoloLens and it proved to be unsuitable, then our only other option would be an Android device. But if we selected a device running Android, then if that proved to be unsuitable, the swap over to a new device would be far simpler and minimal cost in comparison. So I guess what I'm saying here, there's the Microsoft HoloLens is developed using the Microsoft platform, but we could develop something for the ODG glasses in Android But if that didn't prove to be suitable, then we could find another Android device, and then your changeover for the ODG to another Android device is a lot simpler and a lot more cost effective, essentially. So we decided on the ODG. So to summarise, there were a number of points for discussion that came out of stage one. The most important was that the hands-free real-time workflow was proven. The pain points were the microphone. It had its own limitations in noisy environments. The design meant that it could pick up people talking that was nearby, and if a word said was a command, then that ended up being a problem. The other thing was safety. So the heavy frames restricted vision and impaired situational awareness. So some people were uncomfortable talking also, which was something interesting, was that some people were uncomfortable talking to somebody with the wearable, with the glasses on. So that was something that was new to us that we actually didn't think about, but being able to see somebody's eyes without something around it was important to a few people. So this highlighted the fact that Assure is a business that has face-to-face contact with their clients, and we have to be aware of that when we're using that technology. So our conclusion at stage one was that the AR technology is not, and this is generally, is not where it needs to be a viable, scalable solution for enterprise. So the results were still encouraging though. Even with the issues experienced, there were still productivity and efficiency gains made. But the thing here is that we had to change our thinking. We needed to source another solution, and it didn't have to be AR glasses, it just needed to work. Being flexible enough to change when needed, and by putting aside the glasses paradigm, this enabled us to find the RealWear head-mounted tablet, which we saw earlier. So that's where we went. We went with the HMT. So the HMT is purpose-built for connected worker programs in the industrial enterprise, and is safely controlled with just your voice, even in extreme noisy environments. So global leaders in energy, manufacturing, and automotive industries trust the HMT to empower and connect their workforce. In fact, companies like BMW in the US are reporting up to 70% productivity gains after their mechanics had to switch to using the HMT. And if we think about this around servicing vehicles, it's the step-by-step process. It's when they're doing an inspection, it's still an inspection. There's still steps to be carried out, and most engines are different in circuitry and all sorts of things. So if they're able to be taken through an inspection step by step, then if they have any trouble, then they can call an expert for help. And even if they need to as well, if there's, for example, something that does arise that they need to get some customer approval for, then they can even make a video call to the customer and talk them through it and have that entirely recorded as well. So everything can be done and saved ready for accounts to invoice out. And all of these little sort of micro pauses or micro interruptions of maybe picking up a smartphone and taking a photo and then sending that to somebody else and having to fill out the forms and all that sort of stuff, that all gets pretty much eliminated, and we have what we're after, right? More productivity and efficiency with our connected worker. So with the device, the main philosophy behind that is safety first and technology second. So by being 100% voice controlled and hands-free, that means that not only working more efficiently, now you can use your hands while operating, but it increases the safety. Right? So no more holding phones and tablets, taking your attention away from inside a work environment. And it also works completely with all PPE, so there's no difficulties there. the one thing that we did like about it, if I'll just go back up to that, if we have a look at with the boom arm. Now that can actually be moved out of the way if needed, but what it does provide you with is this unobstructed vision. So, you know, we have complete situational awareness. We don't have stuff, information, you know, hardware in front of our eyes continually. We just have it there when we need it, and even when you're using it, it does not interrupt when positioned correctly. It doesn't interrupt with your vision and your situational awareness as well. The other thing is that it can be attached to hard hats, caps, or worn directly, so there's no heavy weight around the face, and that then transfers to the neck, and as there have been other cases with other devices. And for where needed as well, you can get an intrinsically safe model. So it really did tick all the boxes for us. So our outcome for the project, I think the trial was a success. So, and all the major issues that we had with the ODG glasses were resolved. From the trial, you know, feedback was positive. There was productivity and efficiency gains, but also from the user themselves, that they enjoyed using it, felt it enabled them to provide a better service, and they enjoyed their day more. So the stage where it is at now, we're just going from this particular audit, and now we're looking to integrate the reports back into the existing systems, and once that is done, then we'll move on to deployment. So in summary, there are big gains to be found using AR-powered wearables. It's important to understand your use case and what you want to get out of it, as not all devices are the same. And also remember to be flexible. Technology is changing constantly, and even with the drive to digital transformation, don't forget that people are still central to realising your goals. So as they say in the puzzle of that is digital transformation, the missing piece is the connected worker. Thank you. So now I'll pass it on.
Well, thank you, Lance Bauerfeind, for that look at wearable technology, auditing, inspection, and assessment. And that concludes this presentation.